Okay, so in this lecture, I'm going to talk about complex property restriction, right? I'd like to show that this complex property restriction can be a DL expression, right? So I showed the simple case. Now let's talk about complex case. As you can see, the complex case has topping sum and has spiciness value hot, right? You see that? Maybe, okay, so this was a simple case, right? The complex case has topping, has sum, has spiciness value hot, whole thing. Okay, now that means what? Let me just write this down. So that means, hold on, let's just move this one a little bit. Okay, good. So I have what? Has, oops, let's just use the black. Okay, so has, okay, so it has what? Topping, right? And then sum, and the whole thing, right? So at this point, you know that has topping is a property restriction, and this whole thing now becomes what? Filler, right? So what I'm trying to say is this is now becomes a filler for this property restrictions, right? So this is a property restrictions now. Specifically, it's object property restriction, right? Okay, and then you know what? This whole thing, right? You know that has topping is what? Domain is a pizza, right? So we know that this whole thing is a class representing some kind of pizza. Okay, so now let's just test this using the okay. So just type this has topping, some has spiciness value pizza, right? When you just execute this, you will see this as a result, right? And obviously, not like the previous case, you will see a lot of pizza, right? Pizza, 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 right? A lot of pizza because what? That's something we expect. First of all, at least, right? That's something you should know because you know that this is what? We are talking about the pizza right now, right? The whole class, we are talking about the pizza. So obviously, you expect to see a lot of pizza, right? Okay, now, having said that, let's just take a look at this expression a little bit more time. You know that this is what? If you look at this class, this is what? The pizza class, right? But has what? At least one or more. The sum means at least, right? One or more topping with the hot spiciness. That's what this class really represent, right? So equivalent class is a spicy pizza, right? That's the equivalent class. If you go to the classes and then if you click the spices pizza, you will see that this is the definitions. And then let's look at the subclass, right? Subclass is American hot pizza, and then another subclass is what? Hot veggie pizza, right? And then of course OW nothing is a subclass of everything, so it's obvious it's included here. And then let's take a look at the American hot pizza. Okay, so when you look at the American hot pizza, just click this. You know the American hot pizza is what? It's a type. It's American. It's a American pizza 1. It's an instance, right? See the diamond bar symbol means instance, right? It's an instance of what? Class American hot pizza, right? So now let's take a look at the American hot pizza. American hot pizza is what? It has at least one jalapeno topping, right? It has a jalapeno topping, mean the jalapeno topping is that it's what? Has spiciness, hot spiciness, right? And that's why when you go to the DL query, for the subclass, right? American hot pizza is basically it's what? It's a subclass of a class that which represented by this DL expressions. Okay, so if I just draw this, right? I mean, this is how you should think. So there is a class, right, which is represented by these expressions. And we know that American hot pizza or the hot veggie pizza, right? So let's just talk about this now. So American hot pizza, right? It's American hot pizza is what? Subclass of the subclass of a class represented by this DL expression. Why? Because it says that, you know, as long as, I mean, this basically is saying that what? It is a pizza, right? Which has at least one or more topping with hot spices, right? And obviously, the American hot pizza, it's a, for example, it's a jalapeno topping, right? Which is hot, right? So it should be what? It should be the subclass of this class, right? So this is what? This is the Americana hot pizza, right? Okay, and then same thing, you know, for the hot veggie pizza is somewhere here, hot veggie pizza, right? So this is 1 and this is 2 and this is 1 and this is 2. Okay, so that's something that, I mean, this is how you should think. And then also look at, make sure that go to all these instances and then, I mean, think about it, you know, why these instances are classified as a what? It's a pizza that has at least one topping with spiciness, right? I mean, go through each of them and then find out, and then make sure that everything makes sense to you. Okay. The last thing that I would like to tell you about is a lot of people, you know, probably can be confused because when you look at the American hot pizza, right? You know that this American hot pizza is, you know, that is subclass of a class represented by this DL expression, right? But some people, you know, kind of think opposite because let's just go to the class and let's just click the American hot pizza, right? And you know, if you look at the American hot pizza, it has a lot of toppings. Of course, it has a jalapeno topping, but it has a mozzarella, pepperoni, and tomato topping. As you can see, American hot pizza has it has more constraints. Okay, so it's more specific. But when you look at the definition of the class that provided in the DL tab, right, DL query tab, as you can see, it's more abstract, right? So it has less constraint, and that's why this is this class be what? It's a parent class or the superclass. Now, just like just like this graph, right? I mean, the concept is the same. I mean, for example, you know, when you have for example, okay, so when you have let's see, what is a really good example? Yeah, maybe when you have an animal, right? So let's say animal class, and then what? Let's say in the animal we have dog, and then we have cat, and then we have bird, right? For example, and probably many more, but you know, dog and cat or the bird is obviously a subclass of the animal, right? An animal is a parent class or the superclass. As you can see, the definition of animal is more abstract, whereas the dog and cat and bird has more specific constraints. For example, bird has like 2 wings, right? And dog has 4 legs and extra. It has more specific constraints, right? And has more constraints. For example, another example, it's the doctor, right? When you have when you let's say you have a general doctor, right? And then you have what a specialist, right? And then maybe in the specialist you have surgeons, like cardiovascular surgeons and etc. Right? And if you look at the the parent class, doctor is really like a general, right? And then what? This one is specialist, has more specific constraints. And then obviously this is what? This is narrower, right? And this is what? This is the, let's say, cardiovascular surgeons, right? The surgeon, it's more like specialized, right? More, and then doctor is more like abstract concept. Same thing, okay? Okay, so I'm done. Actually, I need to talk a little bit more, but I think I'm going to, I'm done with this lecture. I'm done about this complex property restriction, right? And in my next lecture, maybe I'm going to talk about this one. I'll say it's complex DL expression, okay? Because it has one more outer layer, okay? So I'll talk about this in my next lecture. Thank you.